Well, hello, everybody, and Happy New Year. Happy 2024. Welcome to the Virtual Planetarium with Pete Lawrence and myself, Paul Abel. And as ever, we will start with the inner solar system and work our way outwards. So starting with the planet Mercury, with the first part of January, Mercury is a morning planet, and it shines at about magnitude plus 0.6, rising 100 minutes before the sun on the 1st of January. It brightens over subsequent days and reaches magnitude minus 0.2, but then rising 90 minutes before sunrise on the 17th of January. So it's probably going to be quite tough to see it.
Yes, I think so. It's also worth noting that Mercury and Mars will appear close together on the 27th of January. They'll rise 52 minutes before the sun, with magnitude plus 1.3 Mars just 21 arc minutes southeast of magnitude minus 0.2 Mercury. And on the 28th of January, Mars appears half a degree to the west-southwest of Mercury. So it's a tricky thing to see, to be honest, but it should be possible.
Worth having a try.
Yeah.
Worth having a try. A much more striking object in the morning sky, of course, is the planet Venus. So from the 1st of January, the morning object rising 3 hours before the sun.
Which is pretty good, actually, isn't it?
It is. That is pretty good. It's shining at magnitude minus 3.9. So really just go outside and look eastwards and you won't be able to miss it. So very, very brilliant.
It's worth noting that we've got Venus in a good position at the beginning of January, but it does start to lose that position. It only rises 100 minutes before the sun on the 31st of January. And this is actually going to be a bit of a trend with the planets as we go into the late winter and the spring period. The planets are going to disappear from view. There's going to be a very barren period at the beginning, or sort of towards the middle, or the early middle, should I say, of 2024, because the planets are just not going to be visible.
No.
And then just as you're getting a bit despondent because you can't see them, they're going to burst back on the scene in the last half of the year. So it's good to get out and grab them now while you can.
Yeah, it is true. But, you know, we've got variable stars, we've got comets, we've got some other things. And the moon is very good in the early part of spring. So
yes,
there are compensations. But as you say, the planets we should make the most of because there'll be shortly a period where they're absent. Sticking with absent, Mars, oh dear, still too close to the sun to be visible. Although it will, by the end of the year, started to become a lot better target. But for now, we should regard Mars as largely a very, very difficult object in the morning sky.
Yeah. Well, Jupiter is still there. Jupiter's really well placed still at the beginning of January, and it's able to reach its highest altitude under dark sky conditions. It's quite bright, shining at magnitude minus 2.4. And if you have a telescope over, what would you say, about 4 inches diameter, you can see a wealth of detail on Jupiter.
You really can. At the moment, the northern equatorial belt's gone through this massive sort of change. It was quite thin and not much detail in it, but it's expanded now, and there's all sorts of dark spots and brilliant white rifts in it. It's quite easy to see the detail in a small telescope. And of course, you've got also the Great Red Spot that should be visible in the 4-inch telescope, although it is becoming harder to see it. I think the colour is
shrinking,
fading
isn't
a bit.
It? Yeah.
It is. So it is becoming tougher to see. So my advice that it's visible in a 4-inch telescope, not actually sure anymore because I haven't looked at it through a 4-inch telescope for a good few years, but I think it probably should be doable.
Well, here's an awkward question for you. The Great Red Spot has been shrinking in length over quite a long period of time, admittedly. Yeah. Do you think it will ever disappear?
So I have no idea. I don't think that it will. It'd be interesting to see what will happen, but you could imagine. It's not uncommon, say, for example, the southern equatorial belt to vanish completely. And then you get a load of spots appear and the belt undergoes a massive revival sequence and reappears all the way around the planet again. I don't know whether that would happen with the Great Red Spot, but it's not uncommon for objects to disappear but reappear not long afterwards. What the mechanism that would drive that be, I have no idea. But Jupiter's still got a lot of mysteries, so I wouldn't be surprised if it didn't actually disappear and reappeared in a different form. But who knows? What do you think?
It's an interesting thing. Well, you get spots which appear, which stay there for quite some time. We had the Great Red Spot Junior,
yes,
for example, Oval BA, I think it was called, wasn't it? And that's basically an example of a short-lived storm system, but it short-lived, still meaning a number of years. And it wouldn't surprise me that we get to a point where the Great Red Spot just gets to a point where it becomes like a regular storm and then dissipates, and then we get other things appearing in its place, perhaps not quite as long-lived.
It could be. I think the thing that differentiates the Great Red Spot from the other spots, though, is the depth. If infrared images show that it goes down quite a long way down, well down into Jupiter's atmosphere. It has a depth and a longevity that the other storms simply do not have. So I think it is a special feature of Jupiter.
But presumably, as it gets smaller, the depth will get less anyway.
Well, you say that. I have colleagues who've been at the University of Leicester have been looking at it. I'm not sure that it has got any shallower. I don't
really.
I think it's still quite a mystery as to how it got started in the first place, because there isn't an equivalent one in the northern hemisphere. It's
no.
In fact, Jupiter's southern hemisphere is very different from the northern hemisphere. I think it's, as Patrick Moore would have said, frankly, we just don't know.
No, very good point. Thank you, Patrick. Okay, well, let's have a look at another gas giant then, which is visible in the evening sky, the planet Saturn. It's an evening planet, but it's losing its battle with the evening twilight at the moment.
Yes.
On the 1st of January, it appears around 20 degrees above the southwest horizon as darkness falls. And there's a lovely 14% lit waxing crescent moon, 4.5 degrees to the east of Saturn on the evening of the 14th of January. But grab it while you can, because it's not going to last for much longer in the evening sky.
No, and then it's gone, and then it'll be a bit better next year, albeit the ring's even more at a shallow angle than they currently are. There we are. Ice giants, they're still around. So Uranus is an object in southern Aries. It's located close to Delta Ariatis, magnitude 4.3. Uranus is magnitude 5.7, so a lot fainter, but that's a good start to look at if you're going to try and find it. I think it's easy to see in binoculars or a finder scope, and in a small telescope, the colour is quite unmistakable.
Yes, that's right. Same true with Neptune, actually. Neptune, you need at least binoculars to see, but you need a telescope to bring out the colour. Neptune is an evening planet as well, and it's appearing south of the circlet asterism in Pisces. It will be losing its position throughout January as it gets closer to the sun, so the evening twilight will just engulf it. So we will lose most of the planets. We've still got Jupiter and Uranus, but they will go too as we go through the next few months. It is an odd situation, actually. I'm harping on about this a bit, but because I write the Sky Guide for the magazine, there are a couple of months where it's quite unusual, but the planets are just gone. They're completely not visible over that period.
Yeah, the funny thing is, isn't it? If you're an amateur that observes a particular thing, so we're both planetary, aren't we? We both do a lot of planetary observing. You kind of feel a little bit redundant during those times. I mean, I said I know we've got variable stars on the moon, but your observing sessions are kind of geared to what you're interested in.
Yes.
And I always find, even though my telescope is permanently set up, doesn't take me long to get out there and get set up. If you leave it a long time, you lose all your rhythms, and it can be.
Oh, you do.
You have to really put some effort into getting back out there. And so it's a bit of an annoyance that the planets are disappearing. I feel cosmologically slighted by it, Pete.
You'll have to switch to the sun.
It doesn't excite me as much as...
the sun is quite an exciting object.
I'm sure it is, but...
And we're getting close to solar maximum, which is predicted for 2025. So
that's true.
There's plenty to see on there. Okay, well, let's have a look at some of the specials which are occurring this month. We've got, when we're losing the planets, as you mentioned earlier, there are comets around at the moment. And we've got 144P Kushida, which is going to be about 2 degrees south of Uranus right at the start of the month. And that's predicted to be about magnitude plus 8.9, which isn't too bad at all. And that one's going to be heading towards the Hyades open cluster. So in February, it'll cross the Hyades, which will make it really easy to find. Even you can do that, Paul.
Thank you. I don't know these days. now I'm wedded to me go-to. I'm not so sure, Pete. So,
yes.
Yeah, but I've that'll be interesting. We've got a couple of comets around at the moment. At the time Pete and myself are recording this, we have 12P, which is, as of today, just gone under another outburst. So these comet magnitudes, you never know. They can brighten, they can do interesting things. So
Pons Brooks, yes, but that's going to be good as well in the coming weeks. So we'll be mentioning that in the magazine as well. And
yes.
Yeah, plenty to look out for, actually. And of course, we've got a big one coming towards the autumn period, which we will obviously mention as we get towards autumn. But we'll keep you updated on that as time goes on. Also related to comets, of course, we have meteors, and we've got the Quadrantid meteor shower, which peaks at about 10 o'clock in the morning on the 4th of January, which means a watch on the night of the 3rd into the 4th is probably your best bet for that one. It can be a tricky shower because the peak is quite narrow in time, and it's cold as well.
It's cold, and you can lose the will when you're only seeing a couple of meteors per hour, but it is worth looking for. On the 4th of January, we have a lunar Clair obscur effect known as Curtis's Cross and Gruithusian's Lunar City. Now, I have seen the Lunar City. It is quite an impressive combination of shadow, except if you look at it in high magnification and it all vanishes.
Yeah,
you do have to look at it. It's definitely an artifact of low magnification and lighting, because if you look at it in higher power, it all vanishes. But it is quite striking.
That is the case with a number of them, actually. They look fantastic when you have awful conditions and you're using low power or a small telescope. But if you use a big telescope, you think, what is all the fuss about? They've just disappeared.
Yes.
Okay, well, on the 6th, it's another moon which gains or two moons actually. We've got Ganymede in transit across Jupiter's disk from 9 o'clock in the evening, and it's joined by Europa at 2207 UT. And you'll see that Io is also occulted by Jupiter at 2247. So plenty going on the evening of the 6th.
Yes, on the 7th, sticking with moons, lunar libration favours the Mare Orientale. So Mare Orientale, this is a huge ringed impact basin on the western limb of the moon. But originally, when this was first discovered, it was on the eastern limb of the moon. That's why it's called Mare Orientale. But the IAU switched east and west round. So now the eastern sea lies on the western limb. So, but it's quite a difficult object to see because the moon has to be tilted towards us. That side of the moon has to be tilted towards us. But it is quite impressive. And if it was on the standard side of the moon we see, it would be a really phenomenal feature, wouldn't it?
Yes, it would. I mean, the Mare Orientale is actually the lunar sea which sits in the middle of that bullseye.
Yeah.
It's the Orientale Basin, which is the much larger feature, which has the two concentric rings of mountains.
Yes.
There's Mons Rux and Mons Cordillera.
Yeah.
And they're quite impressive, actually, if you see them. But you have to use a bit of detective work because the whole structure is so foreshortened when it's on the edge of the moon that it's difficult to work out where bits and pieces of it are. But that's part of the fun of looking at that region, actually.
It is. And as you say, Pete, my own personal way of doing it is to print out a chart of that region early on and go out there forearmed and be prepared to spend about 20 minutes identifying the features. But it's often they're like a magic eye puzzle. All of a sudden, it pops out and there it is. You can see it. And it is quite a beautiful feature. So it is worth looking at.
Absolutely.
We also have a double Jovian shadow transit. Ganymede and Europa's shadow will appear together between 0218 and 0254 UT. But Jupiter sets below the horizon before they cross the whole disk.
Yeah, which is a pity, really, but you might just catch the start of that. There's a very interesting event. I don't know whether you've actually seen any of these, Paul, but on the 11th, if you can grab a view of Saturn in the early part of the evening, you may be able to see Dione's shadow transiting the planet. You need to view the planet as soon as darkness falls from about 1842 UT. Have you ever seen that?
I think I've seen a transit of Dione and a transit of Tethys.
Right.
I've seen their shadows last time. That was using a large telescope, though. But it ought to be possible because the shadows, although very small, they've got very high contrast with the surroundings.
Yes.
So yeah, that's a good one to look out for. I've never seen a Titan transit though, so I'm hoping that one day, not too far away, when the ring plane crossing occurs, we'll get a transit of Titan. But yeah, certainly
Titan is interesting because I have been through, or I remember going through the last ring plane crossing, and Titan was transiting Saturn, but every one was badly timed for the UK. This time, when we start going into, but at least the shadow transits at the end of 2024, the shadow transits of Titan, they're all really well timed for the UK. And other countries like the US won't see them because they're just really badly timed for them.
Well, it's about time we got our turn, isn't it? We had to sit out a load of them last time. So this time, of course, it'll be cloudy, won't it? We know what will happen. Every single one will be cloudy. But at least the geometry favours us this time, if nothing else.
It does. Well, on the 20th, lunar libration tilts the moon the other way, so we get to see the features on the eastern side of the moon, such as Mare Smythe and Mare Marginis. Those are two seas very close to the edge of the moon, but they can be seen fairly well.
Yes, and the Pleiades are 3.5 degrees west-northwest of the 76 lit gibbous moon as darkness falls, so that'll be a nice sight. And then on the 21st, we have another Clair obscur effect. This time, the jewelled handle effect is visible in the mornings, optimal, best seen around 0128 UT. So another nice thing to look out for.
We had a look at that, didn't we? When we were filming the last Sky at Night, there was the jewelled handle was actually visible. That's the Mons Jura mountains.
Yes.
And they're a curved mountain range, and as the dawn of the lunar morning illuminates them, they hang over the dark part of the moon's surface, so lunar night basically. So you can see this arc extending into the lunar night. And I remember the moon was coming up as we were filming, and we sort of questioned each other whether you could actually see it with the naked eye. And I think the consensus was you could.
I think you could. I think you could. I think it was quite striking, actually.
Yeah.
But it's like all these things, whenever you view them each time, the geometry is always subtly different. The viewing angle is slightly different. So it's very difficult to make repeat observations. You'd think with the moon being there and bright and easily accessible, repeat observations are easy. But in fact, they're quite difficult.
Yes, they are. Yeah, they are. Okay, well, let's wander out away from the solar system now into the deep sky, into the stars. And there's nothing quite like wandering outside on a cold, frosty January night and looking up at the fantastic starscape on view. One of the most striking objects is the star Sirius, which is the brightest nighttime star of them all. And from the UK, it doesn't get particularly high in our sky. So what happens is the light from Sirius tends to pass through a thicker layer of atmosphere, which causes it to scintillate or twinkle. And also because it's fairly low down, that light is split into its component parts by atmospheric dispersion. So the twinkling is accompanied by these bright flashes of colour. But the interesting thing about of Sirius is that it's got a companion.
Yes.
Sirius is known as the dog star, so the companion, understandably, is known as the pup star. And they have a 50-year mutual orbit. But at the moment, the separation between them is close to maximum. So it's a good time now to go out and try and see them separated. Have you ever done that?
You know I've done that, and you know I failed miserably. It's very rude of you to ask. I try.
I just enjoy the failure.
I know you do. Unlike you, but you never even try, so at least I get marks.
I've actually imaged it. I have imaged it.
That's cheating. Come on.
It's not cheating. The trick with it is to understand. I've seen lots of people that have come up to me and they've said, I've managed to do it. I've got the pup star. And I've looked at it and I've said, no, that's not the pup star. That's a star quite close to Sirius, but it isn't the pup star.
Yeah.
Because the actual separation is on par with the apparent diameter of Jupiter.
Yeah, so you need a quite high magnification.
You do.
What I do have, and I have never tried this, and I think about it, I should have done. It was a birthday present from Patrick, actually. It's an occulting bar eyepiece. He used to use it for looking at the ashen light. I think I could put it to slightly better use by putting Sirius just outside the field of view, so it's obscured. That might actually be better, because I think on my telescope that'd probably give a power of about 250. So that's a reasonable separation at 250 times. So I think that's what I'll do this time to try and see the pup, because every other time has failed.
Yeah. Well, the other things you can do are trying to view Sirius in twilight before the skies got properly dark, because that tends to reduce the contrast of the primary star. And that's the difficulty. It's that bright glare from Sirius A that causes the issues trying to see the pup.
Yeah,
the pup is about mag 8.5, I think.
Yeah, if Sirius wasn't there, it'd be a trivial star to look at. But unfortunately, as you say, it is rather overshadowed. Okay, well let's hope to have views of the pup star this winter. Sirius can be found very easily using the constellation of Orion the Hunter, a very, very striking constellation, which is now in the southern part of the sky in January. His main form of Orion, made up of two very, very interesting stars, Betelgeuse, which is orange in the top left, and Rigel, brilliant blue-white Rigel in the lower right. So those are the directions I should put out if you're viewing it from the northern hemisphere, from the UK. Down south, it's upside down.
Yes.
But those the Orion constellation will lead you to Sirius. And I think probably one of the most striking features visually about Orion is the belt stars, those three belt stars, which are very easy, unmistakable, I think. Even if it's partially cloudy, you can see the belt stars. They're very striking.
That's what stands out with Orion. And of course, it's the belt stars which are the guide to Sirius, because you follow the line they make down and to the left, and that points directly to Sirius, which is very handy. Really.
It is indeed.
But hanging down from Orion's belt, we have Orion's sword, and that's home to probably one of the most impressive sights in the night sky, I think, the Orion Nebula M42.
Yeah.
It's a favourite to look at if you're starting out in astronomy, and it's a very, very photographed object, because it's a bright, highly detailed nebula. But even if you've done it many times before and you've moved on to other things, it's always worth going back to it and having a look, because when you get your experience and your eyes get really well attuned to looking at the night sky, you just pick out even more detail every time you go back.
That's absolutely true. There is a joy in revisiting old objects that you're very familiar with. The last time I looked at the Orion Nebula was actually at the end of an observing session. I think I've just been observing Mars, and I wasn't quite ready to go in yet. And I had a look, and so I'd been accustomed to visually observing for a good few hours. And I had a look at the Orion Nebula, and the amount of detail, which I hadn't seen before, even with the same telescope, was just overwhelming, because, as you said, you're coming back and look at it afresh with much more experienced eyes. There is a hell of a lot of detail in the Orion Nebula to see. Even a small telescope will show quite a few things.
Yeah, absolutely. Well, the winter Milky Way passes up from the southern horizon through the region to the left of Orion, and from the UK we see it making an appearance above the horizon just to the left of Canis Major, the great dog. That's the constellation which contains Sirius, of course. And here there are two tricky constellations for us to see from the UK, because they are very low down. You've got Puppis, the poop deck, and Pyxis, the compass, which are all part of that huge conglomeration which used to be known as Argo Navis, the sailing ship, which got broken up because it was too big. Unfortunately, most of these Argo is invisible for the UK, but Puppis and Pyxis do point the way to where it is. And there are a couple of nice Messier clusters to be had in Puppis. You've got M46 and M47.
Yeah, they are very pretty. I've actually only ever seen them once, and that was when I was using the university telescope, because it's got quite a good horizon. Just relating to the Milky Way, do you not find this, Pete? The winter Milky Way is actually quite a shadow compared to the summer Milky Way.
Oh, yes.
It is really
you're looking
subtle.
out in the opposite direction to the core, aren't you? You're looking away from the core, and it's hardly visible. You see it in photographs quite clearly, but it's not anything like the amazing structures and brightness you get when you're looking through Cygnus, for example, which is more towards the core. But if we go from Puppis and Canis Major and we head north from there, we'll head into a very well-known and very easy-to-find constellation known as Monoceros the Unicorn. I'm being ironic there because it's really hard to make out Monoceros the Unicorn.
It's a couple of stars if you're lucky. I can't see a unicorn as much as I've tried, but there isn't a lot to see here. But there
is actually. There's a lot of deep sky stuff.
Oh no, by that I mean there are a lot of visual cues to get there.
That's right. Yes.
But as you say, it's an area of sky worth exploring simply because there is actually a lot of interesting stuff there. So it's worth spending time trying to locate it. Procyon.
There's a couple. Yeah, go on. I was going to say there's a couple of things there. If you take the top two stars in Orion, Bellatrix and Betelgeuse, and you extend the line they make to the east or to the left, if you like, by about 1.5 times, you come to a star on its own, which is called S Monocerotis.
Yeah.
And that's the star which is the base of the Christmas tree cluster, which looks like a little Christmas tree, but it's hanging upside down as we see it from the UK. And to the south of that, there's another cluster called NGC 2244, which looks like the number 6 on a dice. And that's the cluster which sits right at the heart of the Rosette Nebula.
Oh, right. Okay. I have looked for the Rosette Nebula. It's difficult to see. So as you say, the little 6 pattern's quite easy to see. But the Rosette itself is quite a tricky object to see visually. I think because it's rather low down. So picking up the nebulosity I've always found quite tricky.
It's low contrast. It's a huge nebula. It's very low surface brightness. I have seen it. I've used a filter to pick it out, and it is quite ghostly. It's quite a strange experience, actually, to see this beautiful nebula in a reasonable amount of detail, I have to say. And you suddenly realise you're seeing it, and you've seen all the photographs of it, and you just are wowed by how big it is.
Yeah.
But it is incredibly faint. The other thing in Monoceros, actually, I'd like to point out is Beta Monocerotis, which is a beautiful triple star.
Is it?
That's all I want to say.
That's all you're going to say. That is a beautiful triple star. But they are all gravitationally bound, aren't they? So
yes, they are.
They are all going around a common centre of gravity. And if there were any planets there, I mean, you'd have quite an interesting sunrise and sunsets, wouldn't you?
You would. Well, it's worth pointing out as well that, or to draw the planetarium to a conclusion this month. We'll just finish by mentioning that Monoceros sits inside the Winter Triangle, which is an asterism formed by 3 stars. It's the Betelgeuse and Procyon, which is the brightest star in Canis Minor, the little dog, and Sirius, the dog star. So those 3 stars form a triangle, which is the Winter Triangle. Not quite as impressive as the summer one.
No, but unlike the Summer Triangle, this is only visible in winter, not all year round. So
that's a very good point.
So a better name. Okay, well, we wish everyone again a happy new year and clear skies and good luck with observing some of the stuff we've been talking about in this podcast. Thanks, Pete.
Thanks, Paul, and happy new year, everybody.